If you look at sort of educational theory, there's lots of theories out there. One of my favorite is ICAP. So this is thinking about learning activities is either interactive, hence I, constructive, active, or passive. So passive might be reading a book or sitting in a lecture. An active might be with a highlighter pen, as you read the book, you highlight a key sentence or equation or whatever. Constructive would be actually solving a problem or writing a piece of code or writing a summary of a chapter of a book as a short 10 or 20 sentence summary. And interactive is chatting with other people. And that might be a teacher-student relationship. It could also be peer-to-peer learning as well, where two students sit with one another. And there's good evidence that as you go up that hierarchy, better learning outcomes happen.
Welcome to Data and AI Mastery, the podcast where we bring you cutting-edge insights, practical advice, and inspiring stories from the leaders shaping the future of data and AI across the globe. I'm your host, Raoul Gabriel-Irma, founder of Cambridge Spark, the leader in transformational data and AI upskilling, career development, and progression. In each episode, I will be diving into real-world case studies of companies harnessing the power of AI to drive innovation, reduce costs, and create new business opportunities. So whether you're an aspiring data scientist, AI engineer, or seasoned executive, this show is designed to give you the tools and knowledge to stay ahead in a world where data is transforming every aspect of business. Stay ahead, stay inspired, stay masterful. Welcome to Data and AI Mastery. Hey Ali, good to see you. How are you doing?
I'm good. Well, thank you for inviting me.
It's great to have you. You know, Ali, we've known each other for, I think it's like over a decade. When I was doing my PhD, I remember teaching on your Java course, so it's been quite a while since then.
It certainly has. Yeah, no, I think, both of us and Java have also changed.
That's true. It's quite dramatically. And since then, you've become the head of the computer science department at the University of Cambridge. That's a super prestigious position. And you're also a professor. So I think in this episode, it's quite a lot to talk about. Today, you're a professor and a head of the computer science department. So what were the milestones to get there?
Yeah, so I guess that once you have a sort of permanent academic job, then the usual things in science, at least, is, building a team around a particular topic area, sort of really finding an area that you're the world expert in. And so that's on the sort of academic side. And for that, I really focus on computer security. That's my thing. How do you both protect people's devices from being hacked or broken into or compromising their privacy? And also, we spend quite a lot of time looking at how to break the current generation of systems. So occasionally we find flaws in products from current companies. And mostly over the last probably even 20 years, I focused on mobile devices. These days, smartphones is my focus area. Sometimes on laptops or embedded systems as well.
All right, so I know who to get in touch when I've got a security issue, obviously. I thought it would be good for episode together, it's to focus on data and AI in the context of education, given you've done a lot of research and you have a lot of experience there. So to kick off, can you walk us through a little bit, what are you currently doing in the edtech space? I think specifically lots of exciting work in STEM, I believe.
Yeah, so I guess after the Java thing, and we kind of caught the bug, as myself and a colleague, Andy Rice, were really kind of passionate about this sort of how can we use technology to improve teaching. MOOCs were all the rage, right? In the early 2010s, you might remember the massive online open courseware idea.
And so low completion rates, if I recall as well, right? Massive, but lots of dropouts.
That's right. So I think there was a lot of hype about it and some good things about it. But as you say, 100,000 people might start the course, 5,000 people might get to the end of the first video, and 3,000 people actually get to the end of the program. But we're interested in taking some of those ideas from MOOCs and using them to improve teaching in Cambridge. And so we built this web platform to offer interactive videos of a language called Prolog to support teaching.
I remember Prolog.
Alongside some auto-marked work and so on. And from there, we ended up talking with people in engineering and physics and other subjects about this idea of trying to use computing to improve teaching. And that's what really got us into what's now become isaacphysics.org and adacomputerscience.org, which are these big web platforms to support teachers in UK schools, predominantly in the secondary school market. So this is from mostly ages of sort of 14 to 18, GCSE and A levels. And so in this platform, over the last decade, we've helped over 500,000 people make over 170 million question attempts on our platform, which is something we're really proud of. And you were talking about, stats or data. There's so much data you could crunch on how the platform is used. For me, my favorite number is the number of question attempts. And the reason I like that number is that that sort of shows real effort on the part of the student, right? They've had to sit down, read a question, try and solve the problem, and send us an answer. And as soon as they send us an answer, we get back, we can then take some action, right? We can then say, well, I'm sorry you've not got it right, but here are some prompts or some hints to help you, or congratulations, here is the next question you might like to think about. And so I feel that question attempts is much better than page views or other stats that you might try and think about.
Is it because it's a good engagement indicator and progression for the learner?
Yeah, and also if you look at sort of educational theory, there's lots of theories out there. One of my favorite is ICAP. So this is thinking about learning activities is either interactive, constructive, active, or passive. So passive might be reading a book or sitting in a lecture. An active might be with a highlighter pen, as you read the book, you highlight a key sentence or equation or whatever. Constructive would be actually solving a problem or writing a piece of code or writing a summary of a chapter of a book as a short 10 or 20 sentence summary. And interactive is chatting with other people. And that might be a teacher-student relationship. It could also be peer-to-peer learning as well, where two students sit with one another. And there's good evidence that as you go up that hierarchy, better learning outcomes happen. So that's why, question attempts for me is nice, because that's a constructive activity, at least if we set the questions correctly.
Great. So can you walk us through a little bit, how did data support, making progress along that ICAP framework? So it sounds like you're optimizing for question attempts. But I guess what sort of data point did you need to track in order to, come up with interventions and recommendations in order to drive those question attempts? What sort of data infrastructure did you need?
So one of the things on our platform that we sort of take as an important starting point is that we try and record and keep a track of the user's journey. So we can have a log of events, of activities that the person has done over time. And that allows us to then look and see what improvement has happened over the long view. So if you have users who come back week after week, month after month, we can then see what their progress has been like. And so we've used that in a variety of different experiments to try and explore whether, are they now ready to, for example, tackle this question, or how much improvement can we see? The other thing we do is we compare our data with other providers. So we've had several comparisons with UCAS. That's the University and Colleges Admissions Service. So retrospectively, we can look back in time and say, someone 2 years ago started learning the platform. They've now set their A-levels. They're now at a university. What does that career trajectory look like, and how do they compare to other people that don't use Isaac or Radio Computer Science, and what were their outcomes and so on.
I see. So that's essentially a measure of performance or benchmarking against other approach that kind of gives conviction in terms of the platform engagement and interactivity. Can you walk us through some examples of how data is utilized or could be utilized in order to kind of like move up in terms of those analytical capabilities? Are you making predictions about students? Are you making recommendations based on the data?
So I think one of the nice, really simple ones that I like is, because we have so many students attempting a particular question, we can work out what common wrong answers are coming in on the platform. So you see a question, you might get 100,000 answers over a period, and you see, well, maybe 60,000 are correct. But let's look at the other 40,000, right? Maybe 10,000 of those have all written, instead of the correct answer of 2 times pi, have written pi over 2, right? Then we can go back to the content creator and say, why are all these students writing pi over the 2? Is it a miscommunication on our part? Maybe the question could be interpreted in 2 different ways, so we could fix that. Maybe it's a threshold concept or some other issue that that we can help them with their learning. So the question isn't wrong, but they have a misconception that we need to try and address. And so then what the content creators can do is can put in feedback. So if they put in a common wrong answer, we can give them an extra hint or a prod to say, have you thought about this? So our general mantra is you don't want to give the answer at any point, but we'd like to help those that are struggling with some scaffolding, right? And so we've done various studies looking at that scaffolding track and seeing that as students get more confident and more competent at questions, they use the scaffolding less.
Great. That's fascinating. So since we're talking about, I guess in a way, intelligent automation to some extent, I guess it's a nice segue into the world of artificial intelligence. What are your thoughts around what's happening right now in the space of LLM and whether it's an opportunity or a threat for education? Like, how do you think about it?
How do I think about it? Well, we're using LLMs ourselves at the moment on the platform for marking short free text questions. So it is really useful. So you look at, for example, the computer science A-level syllabus, there's quite a lot of the exam questions are short free text question responses. And one of the things we like to do on the site is provide automated immediate feedback to students. And historically, it's been quite hard to give feedback for that kind of question. And yet that is the kind of... Sorry?
Why is that important to give that sort of immediate automated feedback? Sounds like it's a holy grail of education, I guess.
Well, if you think about it from the perspective of the student, they're doing their homework, right? And and those that are motivated and want to do really well, if we can give them feedback and they can improve so that by the time they've finished their homework, they've done as well as they possibly can, that's fantastic. From the perspective of the teacher, it means that there's less marking to do. We provide the teachers with a mark book for the homework sets they've set on Isaac or Ada Computer Science, and they can look through and say, well, no one managed to get question 5 right? There's something with question 5 that I should run through with the whole class. They can see, Johnny didn't do his homework, so I should have a chat with Johnny. And then maybe some of the class really struggled on questions 1 to 4. A different part of the class struggled on other questions. So the teacher can then make some decision. Do they want to set a different set of homework set for those different cohorts? Maybe they'd organize a classroom activity that might differ in terms of helping learners. So it provides teachers also with a really valuable tool to try and take a data-driven approach in their own classroom activities. And then if you look at the STEM Smart program that he runs, this is the university's program to try and support students trying to get into university. Again, there we couldn't run that program without automated marking because the number of students we have in the program versus the amount of resource we have meant that we couldn't possibly give that level of feedback feasibly. And perhaps that's also true for many teachers. You could imagine, we don't use it at the moment, but you could imagine using an LLM to generate a short free text response to the student's work. Teachers just don't have the time to write half a paragraph of text for every student for every question.
Yeah. So, that resonates a lot because, as you know, at Cambridge Spark, we also have a platform to give feedback on code as students write. And having access to immediate feedback really helps to unlock, really helps with engagement of the learner, make progress, so better learning outcomes. LLMs are really good now to offer that feedback. But what are the downsides then? Because, we're saying learners get more personalized feedback faster. That's great. It reduces the load on teachers and, especially in an environment where you really want to scale teaching delivery, that's really handy. Are there any downsides that come or any sort of concerns?
I think educators are also concerned, right? Because the same tools that we're using for this very positive activity, there are uses of it which I think result in bad learning outcomes on the part of the student. So if the student just uses some AI module to write their essay for them and takes no intellectual engagement with that activity, or they use, Copilot to write their code and they submit it, they may get a perfect answer, but nothing's passed through their brain, right? We haven't trained the neural network in the head of the student, which is the goal of education. And equally well, I don't think that it's always the case you should be, only going back to pen and paper, right? That there is something very useful about AI that we ought to also be thinking about.
Well, so that's interesting because, you and I are both computer scientists. When I did my undergrad and PhD, I was writing code basically almost manually, right? Like the IDEs would have a bit of autocompletion, guess it was cute back in the days, but, used to that world. Now with LLMs, I guess not only can they be used to provide feedback on free text and as it, but they can also produce a lot of code. And you're the head of the computer science department. So how do you think about the future of coding, right? Because it feels to me now, maybe new students or junior software engineers, they can rely on those tools that produces all of the code. So how can you assess that somebody has learned coding, has learned the fundamentals, and understand what's spitted out? Because often what's spitted out is often correct. So where do you stand on this kind of like dilemma between, the field of writing code seems to get more and more automated, but at the same time, as an educational institute, we have a duty to assess, people's knowledge and skills and help them learn the right things, right? So it's a bit of a philosophical debate here, Ali, but I'd love to hear your perspective, comparing from 10 years ago to today, I guess.
Yeah, so I think 20 years ago to today, like 20 years ago, we were not doing very much teaching of, we're doing a lot of teaching of how to program a computer in terms of the traditional, I sit there and type out my Java or Python or Prolog or Fortran program. And as you say, the tools are quite basic in terms of manipulating of that program. But we were not doing so much in terms of teaching the other way of programming a computer, which we now know, which is data-driven, right? So we haven't just got, the generative AI models, but we've got lots of other machine learning models that we can and do use to program our computer. And so I think we do need to make sure that both at school level and at universities, we teach the traditional programming model and also the data-driven programming model. Now, within the programming space of writing out your code, as you say, now there are also ways in which computers can assist students in that activity. And this reminds me a bit of the analogy with why do we still teach primary school kids how to multiply and divide and conduct arithmetic, right, with pencil and paper? And that's because we want to train their brain to understand those fundamental areas of mathematics. And so I think by analogy, there's a space in education for teaching people programming and making sure that they can do the basics. Even though, we can give a primary school kid a calculator and they can use it, we still value that and we think education is important and they can do those operations themselves. But then at some point we shift gears in education, right? By the time we get to sixth forms and universities, many exams allow calculators. And by analogy, I think, there's a space for assessments to also include the use of those tools as well. And so we need to do, I think, some assessment that looks at the fundamentals, some assessment which you might say, because many of our graduate students do go into industry and industry careers, is more representative of the work that they're going to go to in the end. And we have to be cognizant, of course, of that worry that you just expressed of, do our students, how do we make sure they've really demonstrated they're understood what has been produced in an interaction with an LLM other than it looks about right?
That's super interesting because it sounds like, if we use the maths and calculator example, there's a bit of a tension between we want to teach you maths on pen and paper because it teaches you about problem solving or it's a very structured way of learning. But at the same time, if you just want the answer, the calculator is the best way to do it. The tool will give you the right answer faster. So it's kind of like a tension between teaching maybe more repurposable learning mindset and skills versus getting the answer. And we're seeing the same in coding, perhaps. Are you suggesting that through learning coding with computer-assisted tools, you're learning sort of maybe meta-level type of concepts that might transfer in your career, critical thinking, problem solving, which are harder to do?
So I guess if we go back to the calculator example, I think there's another thing that by teaching the arithmetic that happens, and which is other checks of whether you've got it right. So it's very easy for the calculator to miss out a decimal point or to switch two numbers or not actually press a key for a number. And so we hope that, whilst using a calculator, students will also go, is that a big number? Is that about the right number that I should be expecting? And the same thing I think is true for coding, where you have this interaction with a Copilot or other LLM technology. But what comes out, you need to be able to critically evaluate it. And also to a certain extent, I did spend a little time with Copilot, admittedly some time ago, asking it to do some security code, right? And one of the things I put in was hashing passwords, which is a common thing that we need to make sure works properly for systems that do use user authentication. And if you ask it, to complete #password in Python, it produced, at the time at least, quite a poor answer, one that was not using good algorithms and so on. Whereas if you put in #password PDBKF2, right, specifying the algorithm that you wanted, you got a much higher quality answer. So if we're not teaching our students the fundamentals, they might not ask the right questions, but get the right answers.
Great. So teaching the fundamentals, like arithmetic or coding, teach you skills that are really helpful for, I guess, verification, challenging, criticizing the output that might be produced from Gen AI or an automated algorithm, so that those are still valuable and those are transferable across perhaps other disciplines. So maybe that's the win. So there's still a place to learn how to code.
I think so. And I think this question of, are you asking the right question? Right? Because is also fundamental. Because if you don't ask the right question or you don't convey that clearly, you're not going to get an answer that's meaningful to you.
Yeah. So I guess if I take you in a different direction, right? So the skills to succeed in the future, asking the right question seems to be one. So would you say that's data literacy, critical thinking? What are skills comes to mind that will be really useful over the next 10 years?
So as I sort of highlighted, one of the shifts that we've already seen is this increasing importance in people understanding not just how to do the traditional programming, but how to do the data-driven programming. And that's not just LLMs, but the wider set of machine learning approaches. And arguably, maybe in the UK school systems, in fact, many other school systems have got to catch up with that. It's an area that we ought to improve further. And then what else would I say that AI is sort of transforming? I guess the fundamentals we've already talked about. One of the questions for me is also how much we can use AI to support education itself, right? So we've talked a little bit about how it's transformed it so far, but I think there's lots to go in that space as well, in terms of how we think about using computers to give feedback and support students. There's that classic thing of not wanting to give students the answer, but just enough of a teaser, a little bit that just helps them, nudges their brain along. And so can we use these kinds of platforms to do that? That will be kind of interesting.
I've really enjoyed the discussion on AI in education, Ali. So maybe now I'll ask you a quick fire round of questions. So the first one, what's a contrarian view you have in the industry? I guess the pen and paper one could be a good one, but any other that comes to mind?
Well, at the moment, there's a lot of discussion about, is AI going to be a really negative thing from a climate change perspective? Is it going to suck all the energy that we might want? I guess my contrarian view is that I don't see that really emerging as a thing. I think there's such huge scope for hardware improvements in terms of efficiency, lots of optimization in the traditional software engineering sense of it, and even probably much more efficient models that we can discover that use a lot less energy, right? So DeepSeek, for example, is the latest one that's popped out.
My next question is, How do you stay updated as a leader? But I think I know the answer.
Talk with your students, right? The students are amazing at keeping you up to date with things. There's a few things that I do that I really love, but one of them is probably a highlight of the week for me is the weekly reading group. So each week, all of the PhD students and postdocs and I get together, and the deal is you have to read the paper beforehand and come ready with some questions, comments, and feedback. And we have I have some former students that join regularly, some people from industry that dial in as a hybrid meeting, and it's always a really interesting debate. And so many sparks fly off that, right? Not just the paper you've read, but then someone will say, well, this is a bit like the other paper I read, or this is a bit like this other thing I found out about. And so that's a wonderful aspect of academia and of university research that I love.
All right, next. Very quick questions. What was your favorite subject at school?
Maths was my favorite subject at school. I did love maths.
What's your favorite music genre?
So I have three different genres I really love. So folk music, I'm a real fan of folk music, spend a lot of time playing folk music. Rock, very much into rock, and also jazz. So those would be my sort of three, if I'm allowed three.
Interesting mix. Yeah, absolutely. And last but not least, I know you know what's coming and I expect a really good answer on this one. Favorite programming language?
Favorite programming? This is really hard because I have many things about languages that I love and also things that I don't like, and all the languages I do love.
Fair.
But I guess the language I guess I learned first really well was C in the 90s when you would write websites in C.
Oh my God.
And then the language from the noughties was probably Java. In more recent years, perhaps Python. I want to find some time to really invest in Rust. So it's hard to pick one, but I think if there's a theme, strong static typing is a thing that I like. And so maybe that's what appeals about Rust as a thing that
I understand.
Out at the moment.
All right, Adi. I've really enjoyed our conversation. Thank you for being on the podcast.
Oh, thank you.
I've loved this episode with Ali. I've known Ali for a long time, so it's great to finally have him on the podcast and have a really interesting discussion. There's many really cool takeaways in the field of education here. One was really great to hear about the ICAP framework to measure students' engagement across different dimensions, so interactive, constructive, active, passive. So having this kind of like solid framework to ground what you measure, that was really interesting to hear about, and that's definitely helped the ISAC platform, build features and improvements to drive student engagement. So great to hear about that. We discussed a lot about the future of education with AI. In particular, what are the skills of the future now that AI can produce a lot of code and often also solve a lot of maths? And it boiled down to asking the right questions. So critical thinking, how can we help students build that acumen so they can criticize the output and challenge it? That's really a skill that will be a premium in the future. These topics resonated a lot with what we do at Cambridge Spark. We teach data and AI to large enterprises and students so they've got the skills to succeed in this new world. At the same time, we've built a learning platform that gives personalized feedback using AI for students for those exact reasons we've talked about, to provide personalized feedback, to drive further engagement, and really increase the learning outcomes. So it's great to hear that coming from Ali as well. So all in all, feel really optimistic and the future is really bright. Thank you everybody for tuning in to the Data Mastery podcast. Thank you for tuning into this episode of Data and AI Mastery. If you found value in today's discussion, make sure to subscribe so you never miss an insight from the leaders driving the future of data and AI. And if you're a data and AI leader looking to upskill your workforce with the fundamental data and AI skills to transform your business, Cambridge Spark is here to guide you every step of the way. be sure to reach out to us on LinkedIn or on our website, cambridgespark.com. Until then, be sure to keep pushing the boundaries of what's possible with data, and remember, mastery comes with continued learning and action. Until next time, stay ahead, stay inspired, and stay masterful.